Alright, so these are going to be your notes for 6-3. We're going to be talking about binomial radical expressions, and you're going to be able to add and subtract radicals in this section. So just like we have like terms, we have like radicals. And like radicals are radical expressions that have the same index and the same radicand. So they have to have both in order to combine them. So here are a couple of examples of how to do that. In our first one here, they're both the square root of 2, and we have a square root of 2 here. So this is like saying we have 1 root 2 plus 3 root 2's. So together we get 4 root 2's. Again, in this one here, you have a cubed root this time. The index is the cube root. Same thing here. And they have the same radicand, so we're good. So now we can look at the numbers in front. Remember, if there's not one there, we know there's really a 1. So then now we can say 1 take away 5 is negative 4 cubed roots of 7. So sometimes I like to think of them in terms of something else. So in this case, think of the third root of the cube root of 7 as like a car. So in this case, I have 1 car minus 5 cars, I get negative 4 cars. Just make it some arbitrary thing so that way you can kind of understand. That's really easy to add and subtract them. Again, we do the same thing with variables. There's really a 1 there. We have the square root of 5xy, square root of 5xy, so we're good. We're allowed to add those together. So I have 1 tree, let's say, plus 8 trees, and I'm going to have 9 trees. So that's how I think of it. It makes it a little bit easier to add them together without getting confused with all the variables. And then finally, in the last one, we check to make sure we have the same index, yes. The same radicand, yes. So now I can add those two things together or subtract them. 1 minus 8 is negative 7, so I have negative 7 cube root of 9x squared y. So this is a little bit confusing, I think. It's basically what I just told you. If you have the same index and the same radicand, you can just add a and b together and pretend that those are some arbitrary things. You get a plus b. And then same thing when you subtract as well. So let's try a couple of examples. In A, you're trying to find the simplified form of each one. So I have 3 square root of 5x minus 2 square roots of 5x. So that leaves me with 1 square root of 5x. In this example, we cannot combine these two because even though they're both square roots, I have the square root of 7 and the square root of 5. So this is the simplest form we can get. This one, they have the same radicands, but the indexes are different here. A cube root here and a fifth root here, so again, cannot combine those two. Take a second to pause the video and try to combine these 3 at the bottom and see if you get them right. Alright, and here's the answers for those first 3 questions. The first one we cannot combine because they have different indexes, and the next 2 you can combine, so you look at what's in front. This time you're adding them together. Look at what's in front. This time you're subtracting them to get your answers. Alright, so in this question, the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth of an inch. So you have to understand a little bit more about geometry. So you have to think way back to last year when you learned this in geometry. If the side of the square is 5, and this side of the square is 5, and this is 5, let's use this red one up here for an example. This is 5 inches, and this is 5 inches. What is the length of this? What is the length of the diagonal? If I cut a square in half, what's the length of the diagonal? Remember, this is a right angle, so this is a 45, 45, 90 triangle. So you have to know your special right triangles for this, and hopefully you do, and hopefully you would know that the side length, just this piece right here, is going to be 5 times the square root of 2. So now the question's asking you to find the perimeter of this figure. So if this is 5 root 2, you know that this is going to be 5 root 2, 5 root 2, 5 root 2, all the way around, blah, blah, blah. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can do 10 times 5 square root of 2. Or you could add them all together. It's up to you. your answer becomes 50 root 2, and that's the most simplest form you can get. So that's your final answer. Okay, so sometimes you have to simplify before you can add and subtract. Knowing what we know right now, you would say, I can't simplify these because even though they have the same index, they have different radicands, so I can't do anything with them. Since they have the same index, we want to make them have the same radicand, and the way we do that is to simplify within each one. So square root of 12 we know can be broken down because we know that 12 is the same as 6 and 2, which is the same as 2 and 3. So I have a 2, a 2, and a 3. I can write those in order, 2, 2, 3. And since it's the square root, I want to circle the pairs of numbers. Once I circle a pair, I cross it out, I write it one time, and then whatever's left over goes underneath the house. So 12 can be written as 2 times the square root of 3. 2 times the square root of 3. Now let's try 75. So 75 can be broken into 25 and 3, which can be broken into 5 and 5. And if I circle all my pairs of numbers, or all the prime numbers, and I write them out. Now since the index is 2, I'm circling pairs. I have a pair of 5s, so this becomes 5 times the square root of 3. So the square root of 75 and 5 root 3 mean the same thing. And then finally, root 3 is already in simple form, already has the same radicand, so I'm going to subtract root 3. Now, you can simplify this. I have 2 root 3's, I add them to 5 root 3's, and then I take away 1 root 3. So I have 2 root 3's added to 5, that's 7 root 3's, and then I take away 1 more, so that's 6 root 3 would be your final answer for simplifying something that looked like we couldn't simplify it. Take a second to pause the video and try this one. It's a little bit more difficult. I will show all my work as well. Alright, so here are the answers for this question. Let me just explain really quickly what I did so hopefully you can follow. So the first thing I had to do was make all of these look the same, and remember that they're cubed roots this time. So I'm going to make the tree just like I did last time. I break down my 250 until I get into the prime factorization. I have 3 5's and a 2. So I write 2 and then 5, 5, 5. The reason I circled 3 5's is because I'm taking the cubed root, which means I have to circle my triples. Once I put a circle around them, I cross them out, write them one time. Anything that's left over gets put inside the house. So the cube root of 250 is the same as 5 times the cube root of 2. Same thing with 54. I break down my 54 until I can't anymore. I have a 2 and 3 3's. So I circle my 3's, cross them out, write them one time, and then I write whatever's left over inside the house. So the cube root of 54 is really the same as 3 times the cube root of 2. Then finally, for the cube root of 16, I broke it into 4 and 4, and then from there 2, 2, 2, and 2. So I have 4 2's this time. But again, since the index is 3, I'm circling a triple, or 3 of the same number, crossing them out, writing it one time. Anything that's left over gets put in the house. So now these are in the simplest form they can be. I add these two together and then subtract 2, and I get 6 times the cube root of 2. And again, make sure that you write your answers clear enough that this doesn't look like 6 cubed times the square root of 2. You want to make sure that there's a little separation there so I know that they're two separate things. Okay, so when we're multiplying first, you're going to multiply just like you would any normal binomial. And the way that we multiply binomials is FOIL. So you're going to do the same thing here. First, outside, inside, last. So my first is 4 and 5. That's easy. 20. My outside numbers this time, let's see if I can erase this. Nope, it doesn't let me erase. There we go. Outside numbers this time are 4 and 4 root 2. So remember, you're multiplying them together and adding it to 20. So 4 times 4 is 16 times the square root of 2. Then I'm going to do my insides, here and here. 5 times 2 root 2 is 10 root 2. And then finally, my last one I'm going to be adding. It's 2 times 4, which is 8. And then root 2 times root 2, which is just 2. So now this can be simplified even more. So now I have 20 plus, I'm going to put combining these terms here, 16 plus 16 root 2 plus 10 root 2. And then my last step is to say 36 plus 26 root 2. Pretty easy so far. And those pretty much aren't going to get any more difficult than that. So pause the video and try this one. And here are your answers. Okay, so you might have heard the word conjugate before. And conjugates are expressions like the square root of a plus the square root of b and the square root of a minus the square root of b. The only thing that's different is the sign in between the two numbers. So they're always going to be opposites. So let's look at this example here. We have 5 and root 7. This one is subtracting, this one is adding. It's really important to know the vocabulary word conjugates. I'm going to say it a lot when we start rationalizing. So conjugates are really helpful because they help us give us a rational number. So we're going to FOIL these just like we normally would, and it's going to work out really, really well. We're going to get 5 times 5 is 25. Then we do the outsides is plus 5 root 7. The insides are minus 5 root 7. And my last ones here, it's going to be negative root 7 times root 7 is 7. So now I have plus 5 root 7 and minus 5 root 7, so those are actually going to cancel out and go away. So all I'm left with now is 25 and a minus 7. 25 take away 7 is 18. And 18 is your answer. So we went from all of this messy problem here to just the whole number 18. Try multiplying these two conjugates. Pause the video here, I'll put the answers up in a second. So multiplying conjugates are pretty easy. Really, you do FOIL, but you only have to do the first and the last because the inside ones are going to cancel out. In order to skip the O and the I in FOIL, you must make sure that they are conjugates. If they're not, you will miss a step and you'll be missing a whole middle term of your expression. So be really, really careful and make sure they're conjugates before you skip the outside and the inside part of FOIL. So why do we need to know how to rationalize? Well, we need to know how to rationalize because we're not allowed to have a radical in the denominator. So in order to rationalize this expression, you're always going to multiply by the conjugate, which is why you need to know that vocabulary word. So if I ask you to multiply by the conjugate, you know what I mean. The conjugate is going to be the square root of 5 plus the square root of 2. Because remember, I'm just doing opposite sign right in the middle of the two numbers. And in order to multiply by the conjugate, I can only multiply by 1. And the way I multiply by 1 is by multiplying something over itself. So I'm not changing the expression at all because all I'm doing is multiplying by 1. Now let's multiply across the bottom first because I think that's going to be easier. You're going to FOIL your outside, the first, which is 5. Root 5 times 5 is 5. Your outside, square root of 2 times the square root of 5 minus the square root of 2 times the square root of 5, so those go away. And then you'll do your last, which is going to be minus root 2 times root 2 is 2. So now when we multiply the numerator, we need to remember to distribute that first number to both places. 3 times root 2 times root 5, 3 root 2 root 5, plus 3 times root 2 times root 2. So now we can simplify this a little bit more. We know from the last section that we can multiply when things are next to each other and they have the same index. So this is going to be 3 times the square root of 10 plus 3 times the square root of 4, which is 2, so I'm really going to multiply 3 times 2 divided by 3. So that's going to be 3 root 10 plus 6 over 3. And now I can do one more step. I can simplify this. Because I have a single number on the bottom, I can simplify if I can simplify both numbers. So this is really going to just end up being root 10, because 3 divided by 3 is 1, so it's like 1 root 10 plus 2. And you get that for an answer. So now we've gone from this complex division problem to just a binomial here. Pretty easy. So now what I want you to do is pause the video and try these numbers. But before you pause the video, put a little star next to number 6. And here are your answers for those two problems. Alright, so the last thing I want you to do is just try these problems here. Pause the video, give yourself a second, try, even if you only do, half of them, at least try some from each section, and I'll put up the answers for you. Alright, so this is the end of section 6.3, so just check your answers, and I'll be checking your notes in class tomorrow.